Have you ever thought about what could suddenly trigger a shift in our planet's climate? And I don't mean gradual changes over centuries, but a dramatic, near instantaneous switch. Well, around 12,900 years ago, that's precisely what seemed to have happened in a period called the Younger Dryas. But what if this sudden climate shift was not due to terrestrial events, but rather a result of a catastrophic cosmic encounter? Yes, we're delving into the realm of the Younger Dryas impact hypothesis today, a controversial theory that postulates our past and potentially our future might have been or could be significantly influenced by events not just on Earth, but in the cosmos. Buckle up, because things are about to get chilling. When we think of the past, we tend to think of a linear, steady progression. But what if I told you that sometimes Mother Nature prefers to take detours? Enter the Younger Dryas, a dramatic reversal in our planet's warming trend that took place around 12,800 years ago. After the last glacial maximum, approximately 20,000 years ago, Earth had been steadily warming up. Ice sheets were retreating, and life was adapting to the post-Ice Age world. However, this warming suddenly reversed around 12,800 years ago in an event we now call the Younger Dryas. Within a decade, temperatures in the Northern Hemisphere plummeted, causing a rapid expansion of ice sheets and a sudden shift in ecosystems. This period is named after a flower, Dryas octopetala, an alpine species well adapted to cold conditions. The dramatic increase in the pollen of this plant in sediment layers from this time is a testament to the sudden shift to colder conditions. Imagine a world where in a human's lifetime, familiar landscapes transformed into frozen tundra. Rivers that once flowed freely froze over, and the great mammals of the Ice Age, like the woolly mammoth and saber-toothed cat that were on the decline, got an extended lease on life, though ultimately short-lived. Now, the Younger Dryas lasted for approximately 1,200 years, and then almost as abruptly as it started, it ended. Around 11,600 years ago, temperatures started to rise, and within a human lifespan, they increased by about 7 degrees C in Greenland, signaling the end of this cold snap and the beginning of the current interglacial period, the Holocene. This dramatic period of climatic upheaval left a deep impression on the planet and potentially on the humans that lived through it. Now, the question that has sparked numerous debates among scientists is, what caused the Younger Dryas? When we think about extinction events and dramatic shifts in the Earth's climate, our minds often leap to the impact theory. We've all heard about the meteorite that wiped out the dinosaurs 66 million years ago. But could a similar celestial event be responsible for the sudden cooling during the Younger Dryas period? The Younger Dryas impact theory, also known as the Clovis comet theory, suggests that a massive impact or airburst from a comet or meteorite occurred around 12,800 years ago, triggering this sharp return to near-glacial conditions. This hypothesis was first proposed in 2007 by a team of scientists who found evidence of an extraterrestrial impact layer at multiple sites across North America. This layer is rich in magnetic grains with iridium, magnetic microspherules, charcoal, soot, and fullerenes with extraterrestrial helium, all of which are evidence for an impact event. This evidence, they proposed, suggested a cosmic impact event that caused large-scale wildfires, disruption of ecosystems, and the rapid cooling effect leading to the Younger Dryas. The theory also proposes that this impact event led to the extinction of many of the North American megafauna, such as the woolly mammoths and saber-toothed cats, and disrupted the Clovis culture, one of the earliest known human cultures in the Americas. The potential impact site has been a topic of discussion and investigation, with the Younger Dryas boundary-strewn fields stretching across several continents. One possible crater, the Hiawatha Glacier impact crater in Greenland, is currently a strong candidate. However, the impact theory has been controversial since its inception, facing considerable challenges and sparking heated debates in the scientific community. After all, a cataclysmic event of this scale would leave a substantial footprint in the geological record. So why do we see inconsistencies in the data, and why do some researchers struggle to find the evidence others claim is clear? Let's delve into the controversy and the ongoing hunt for definitive evidence. Evidence is the cornerstone of any scientific hypothesis. So, what evidence supports the Younger Dryas impact hypothesis? It's a multidisciplinary puzzle with pieces drawn from archaeology, geology, paleontology, and even astronomy. To start, there is a distinctive layer of sediment known as the Younger Dryas boundary, YDB. This layer, dated to approximately 12,800 years ago, is found at various sites around the world, and it's notable for its high concentration of soot, indicative of widespread wildfires. This soot layer could suggest that an extensive burning event occurred around the time of the hypothesized impact, potentially due to a fiery airburst or impact event. This boundary layer also contains unusually high concentrations of nanodiamonds and magnetic spherules. Nanodiamonds can form under the extreme pressures and temperatures generated by an impact event, while magnetic spherules are small, spherical particles often associated with meteor impacts or volcanic activity. Moreover, scientists have identified a nearly 20-mile wide crater beneath the Hiawatha Glacier in northwest Greenland. The age of this crater is not yet precisely determined, but some evidence suggests it could be as young as 12,800 years, coinciding with the start of the Younger Dryas. There's also the puzzle of the megafauna extinction. The Younger Dryas period aligns with a major extinction event, particularly in North America, where many large animal species disappeared. The sudden nature of this extinction event fits with an abrupt, catastrophic event like a comet impact. However, it's worth noting that this evidence is still under debate within the scientific community. Several counterarguments challenge the interpretations of the data, with critics arguing that there could be other explanations for these observations. As with any good scientific inquiry, the theory continues to be tested and refined, and it's this rigorous examination that pushes our understanding forward. The Younger Dryas impact hypothesis has sparked its fair share of academic debates. After all, it proposes a major, abrupt event that significantly altered the course of Earth's climate and ecosystems, a claim that naturally invites rigorous scrutiny. One of the key criticisms concerns the age and origins of the Hiawatha crater in Greenland. While some evidence might suggest the crater was formed around the start of the Younger Dryas, the exact dating is not yet definitive. Critics also point out that the impact crater could have formed from a much earlier event, unrelated to the Younger Dryas period. A second point of contention revolves around the nanodiamonds and magnetic spherules found in the Younger Dryas boundary layer. Critics argue that these tiny structures could have formed through other processes unrelated to a cosmic impact, such as forest fires or volcanic eruptions. The theory also fails, in the eyes of some scientists, to sufficiently explain the uneven pattern of extinction during the Younger Dryas. While many large species went extinct in North America, the extinction patterns elsewhere in the world are less clear-cut. How would an impact event selectively cause extinctions in one area and not another? Finally, the Younger Dryas impact hypothesis is also challenged by alternative theories for the climate change. For instance, some researchers favor the idea that changes in ocean circulation caused the rapid cooling, possibly due to massive freshwater influx from melting ice sheets. In the grand scheme of things, the controversy surrounding the Younger Dryas impact hypothesis serves as a valuable reminder of how science progresses. Hypotheses are proposed, evidence is examined, and ideas are challenged. This process, while often contentious, is necessary for refining our understanding and moving science forward. It's the nature of the scientific method in its quest for truth. The implications of the Younger Dryas impact hypothesis, if confirmed, would be far-reaching, reshaping our understanding of Earth's history and the forces that have shaped our world. Firstly, it would mean that cosmic impacts could have a much more direct and immediate influence on Earth's climate than previously thought. An impact event could rapidly change global temperatures, significantly affect the biosphere, and potentially drive mass extinctions. This would underscore the importance of monitoring near-Earth objects and furthering our understanding of cosmic threats to our planet. Secondly, the Younger Dryas impact hypothesis implies a potential link between cosmic events and human history. The Younger Dryas period coincides with the rise of agriculture and the onset of the Neolithic Revolution, the shift from nomadic hunter-gatherer lifestyles to settled farming communities in various parts of the world. If a catastrophic event like a comet impact triggered the climate changes that ushered in this period, then that means the trajectory of human civilization as we know it might have been shaped in part by a cosmic event. Finally, it also raises questions about our future. If such an event were to occur today, the consequences would be devastating. Modern society, with its complex infrastructure and reliance on technology, would be drastically affected by sudden climate changes. Not only does the Younger Dryas impact hypothesis prompt us to delve into our past, but it also forces us to consider our future in a cosmic context. In that way, it's more than just a scientific theory. It's a perspective-altering concept that invites us to ponder our place in the universe and our vulnerability to the cosmos. And so we find ourselves in the wake of a chilling realization. If the Younger Dryas impact hypothesis holds, not only does it reshape our understanding of our planet's history and the powerful, possibly cosmic forces that have shaped it, but it also compels us to consider our precarious position in the universe. An unpredictable cosmic event could, in theory, at any moment trigger an abrupt and catastrophic change on Earth. But remember, while this might seem alarming, it's also a testament to our constant pursuit of understanding the world we live in and beyond, even when that understanding challenges our assumptions and forces us to confront our vulnerabilities. After all, as we navigate this cosmic journey, it's worth remembering, we're not just observers of the universe, we are participants. And as always, thanks for watching. Imagine just for a moment the world going quiet. No buzz of electricity in the walls, no hum of computers or devices, not even the reliable light from a simple bulb. What if, with a sudden jarring shock, all electronics on Earth abruptly stopped functioning? It's an event called a global shutdown, an idea that might sound like it's ripped straight from the pages of a dystopian novel. But in actuality, it's a conceivable reality. A global shutdown isn't about a temporary power outage or a localized incident. Instead, it's a scenario where the intricate web of electronics that blankets our planet, an infrastructure that drives our communication, transportation, healthcare, and economy, grinds to an indefinite halt. We're talking about an event so massive and all-encompassing that it could affect everything from the phone in your hand to the International Space Station orbiting above us. This would plunge us into an era that could resemble the pre-electricity days. Suddenly, we're living in a world that's no longer shrinking because of our ability to travel swiftly or communicate instantaneously across great distances. Instead, the planet becomes a vast, intimidating wilderness again. How could this happen? What could cause such a staggering blow to our technologically tethered civilization? There are a few potential culprits, both natural and man-made, that we'll explore next. The prime natural suspect in our global shutdown scenario is a solar flare, or more specifically, a coronal mass ejection, CME. A colossal explosion on the sun's surface that spews an intense stream of charged particles into space. If Earth lies in the path of these particles, the result can be a geomagnetic storm that interacts forcefully with our planet's magnetic field. A particularly strong storm could induce electrical currents in our power lines, causing widespread blackouts. The Carrington event of 1859, the most powerful geomagnetic storm on record, caused telegraph systems across Europe and North America to fail. Telegraph papers even caught fire. Fast forward to today, and a similar event could be catastrophic, affecting everything from our power grid to satellites and undersea cables, the backbone of our global communication network. On the man-made side of things, we have the ominous prospect of an electromagnetic pulse, EMP attack. An EMP can be generated by detonating a nuclear weapon at a high altitude, which releases a burst of gamma radiation. This radiation knocks loose a horde of high-energy electrons that, moving near the speed of light, generate a powerful electromagnetic field as they're deflected by Earth's magnetic field. This sudden field shift can induce damaging current and voltage surges in electrical and electronic systems, potentially causing a massive continent-wide blackout. Both these scenarios, a powerful solar flare or a strategically deployed EMP, could cause the intricate electronic web our modern world relies on to unravel rapidly, plunging us into a new era of uncertainty and challenge. But what would this new era look like? Let's explore this in the next segment. As we have seen, the shutdown of all electronics is a scenario that can have several causes. But one thing is clear: the immediate and universal loss of power would have catastrophic effects on the preservation of our digital knowledge. This might lead you to question, what would happen to all the data and information that we've stored electronically? The first thing to understand is that the bulk of our digital knowledge, ranging from governmental databases to personal photos, is stored in two main formats: volatile and non-volatile storage. Volatile storage, like the RAM in your computer, requires a constant power source to maintain the information it holds. As soon as the power is cut, the data vanishes. However, non-volatile storage, such as your hard drive or flash drive, retains data even when powered off. So in a sudden universal power loss, any data in volatile storage would be instantly lost. But the integrity of data in non-volatile storage would still be at risk over the long term. Without climate-controlled environments provided by modern infrastructure, sensitive electronic components can degrade, potentially rendering data unreadable. Moreover, even if the physical storage media survive, the machines required to read this data would also need to be re-engineered, a colossal challenge in a post-electronic world. To compound the issue, even the non-digital information would be at risk. The shutdown of power would affect not just the devices we use for work, communication, and leisure, but also the systems that protect our libraries and archives. Without modern climate control systems, these repositories of knowledge would be susceptible to damage from humidity, temperature fluctuations, and pests. Overall, the loss of electronics would thrust us into a new dark age, not merely through the loss of convenience and connection, but through the irreplaceable loss of knowledge. This prompts us to ask, how would we rebuild our technology and our society? Let's explore this in the next segment. The loss of all electronics would plunge humanity into a new era, one where the knowledge and advancements we've worked centuries to achieve could be erased in an instant. We've grown so reliant on technology that we'd almost have to start from scratch, but how would we even begin to rebuild our technological world? First, we need to consider that while our knowledge of technology may be vast, the practical know-how is distributed and specialized. Few individuals have a comprehensive understanding of how to build an electronic device from scratch, let alone the complex machinery and infrastructure that underpins our technological civilization. The ability to mine and refine raw materials, to manufacture components, and to assemble and program a final product are all specialized skills spread across countless individuals and organizations. With the loss of all electronics, we'd be without the industrial and informational infrastructure that makes such distributed cooperation possible. Consequently, rebuilding would likely begin with simpler, more robust technologies. Think steam power, mechanical computing, and the telegraph. These technologies, less susceptible to an EMP or solar flare and simpler to manufacture, could serve as stepping stones toward higher technology. Recovering our current level of technology would likely take decades, if not centuries, and would depend heavily on maintaining social stability and literacy in the interim. It's important to note that this process would not be simply a replay of the Industrial Revolution. We'd be doing this with a fragmented understanding of a technological endpoint, and in a world stripped of easily accessible natural resources by prior industrial activity. The challenge then wouldn't just be how to rebuild, but how to rebuild sustainably. The path to reclaiming our electronic heritage would be a difficult one, full of obstacles and setbacks. Yet it's also an intriguing thought experiment. It makes us question our reliance on complex, fragile technology, and prompts us to consider how we could better safeguard our knowledge for future generations. In the next segment, we'll look at the potential social consequences of such a universal technological shutdown. Buckle up, because it's going to be a wild ride. With the shutdown of all electronics, our societal structure would face massive upheaval. We live in a highly interconnected world where information, goods, and services flow across the globe in mere seconds. But strip that away and we're left with a society much more localized, much more immediate. The effects would be profound and far-reaching. Imagine it. The world's cities, once bustling with technology and human activity, plunged into silence and darkness. Traffic lights stop functioning, causing gridlock on the roads. Public transportation grinds to a halt. Skyscrapers, once brilliant with light, stand dark and abandoned. Supermarkets, reliant on electronic systems for inventory and refrigeration, quickly exhaust their supplies. Our reliance on digital communication would hit us hard. No more internet, no more social media, no more instant communication across the globe. Families and friends would be cut off, possibly without knowing the fate of their loved ones. Governments would struggle to maintain control, their command and control structures paralyzed. In this vacuum, smaller, localized groups could take power. These groups could be benign or malign, but without a unifying authority, conflict would likely arise. That's not to say there wouldn't be benefits. In the wake of such a cataclysm, we'd likely see a return to more communal living, with local resources and skills becoming incredibly valuable. The experience could unite communities in a shared struggle, fostering cooperation and empathy. Education, too, would take on new importance. With our digital repositories of knowledge lost, each piece of information, each skill, each story becomes invaluable. In this sense, every person becomes a living library, their knowledge a lifeline to the past and a beacon for the future. It's a sobering scenario, but it's essential to remember that this is just a hypothetical situation. However, it serves as a stark reminder of our reliance on technology and the fragility of our digital society. In the next and final segment, we'll explore the steps we could take to mitigate the risk of such a cataclysm. Stay tuned. It's time to consider our technological future. So what could our future look like if all electronics were to shut off, plunging us into a world without the technological conveniences we've become so accustomed to? It's difficult to predict precisely, but we can make some educated guesses based on human history and our understanding of societal dynamics. In the immediate aftermath, there would certainly be confusion and panic. Our world is so deeply intertwined with technology that such a massive shift would be disorienting, to say the least. Food and water distribution would likely be a significant initial concern. With no power for refrigeration or to run machinery, our current food distribution system would fall apart. However, we as a species have shown ourselves to be remarkably adaptable. Over time, we'd likely see the re-emergence of older technologies and techniques. Picture candlelit homes, horse-drawn carriages, windmills and water wheels. Communities would need to become more self-sufficient, leading to a resurgence in local farming and other traditional methods of food production and distribution. Communications would revert to pre-digital methods. Physical mail, runners, semaphores and maybe even pigeon post would make a comeback. Without GPS, old-school navigation techniques would need to be dusted off. Expect to see a rise in the use of maps, compasses and maybe even sextants. In terms of rebuilding technology, a complete shutdown wouldn't erase our collective knowledge. Those with the skills and knowledge to rebuild would become invaluable. Mechanics, engineers, scientists, builders, these professions would be crucial in helping society regain some semblance of technological normality. The rate of this progress would depend on the availability of resources and the level of organization in these post-electronic societies. And what of governance? The loss of global communication systems would effectively fragment the world, making global governance as we know it impossible. Smaller, more localized governments would likely spring up, with power structures based on immediate needs and the abilities of individuals within the community. In essence, the world after an electronic shutdown would be radically different. The pace of life would slow, and the world would become a much bigger place. It's a scenario that requires us to rethink our relationship with technology, recognize our dependencies, and perhaps consider how we might better prepare for such an eventuality. But for now, we are left to ponder. What if,